starting chapter 8, which is on similarity. Starting out, we're looking at similar polygons. Our essential question: how are similar polygons related? We start with defining similar polygons. Similar polygons are polygons with the same shape, but not necessarily the same size. Okay, so something that matches up with the shape, but is larger or smaller. One of the things we'll see as we're going through here is when we're saying the same shape, it has to have the same angle measures, and that the sides have to be proportionally the same, which is the two things we're going to start off checking. So example 1, they give us the similarity statement. Triangle ABC is similar to triangle DEF. So the tilde there, or the little squiggly line, is our similarity symbol. What's just above our congruent symbol, what's above the equal sign. We just have that by itself. It's similarity. And we have our two shapes here. So first it asks us to list all pairs of congruent angles. So similar to what we do with congruence, I can look at how my letters match up. So angle A and angle D match up. So angle A is congruent to angle D. Angle B and E match up. So they are congruent. And angle C and F match up. So they are congruent. Then it says, check the ratios of corresponding side lengths are equal. So what we want there is we want to compare our side lengths and make sure that they reduce to the same thing. Okay. One of the key things here is making sure we keep the same thing on the top as we're going through. So if I start with AB to DE, I have 10 to 15, where I'm putting ABC on the top, and that reduces to 2/3. Then I'll do BC to EF, where we have 8 to 12, and that also reduces to 2/3, taking a 4 out of each. And then I have 12 to 18. If I take a 6 out of each, again I get 2 to 3. So they all reduce to the same thing. So then my ratios are equal. The next thing says, write the ratios of the corresponding side lengths in a statement of proportionality. So the statement of proportionality is when I'm writing the segments in proportion instead of the numbers. So we matched up AB to DE. So that was our proportion, that was 10 to 15. We know that's equal to BC over EF. And that is equal to AC over DF. Okay. And this works if you flip everything up top here. If we flipped all of them, we'd have 3 to 2. So when we flip all of these, they'd all be equal. But as you're going through the problem, you want to keep things consistent. And as we'll see on example 2, there are certain times where I need it in a certain order based on how they ask the question. So then we have a theorem here, corresponding lengths in similar polygons. If two polygons are similar, then the ratio of of any two corresponding lengths in the polygon is equal to the scale factor of the similar polygons. Okay. And the scale factor is what we call the reduced ratio. So in the problem above, 2 to 3 would be our scale factor. Okay. When we say it, we say 2 to 3 as a ratio instead of 2/3. That's just how it's done. All right, so it looks the same. You can treat it the same, but we think of it as a ratio or as a scale factor. So example 2 says find the scale factor If two polygons are similar, then the ratio of the length of the two corresponding sides is called the scale factor or common ratio. So in both example 2 and 3, we're determining, actually no, example 2 only, we're determining whether the polygons are similar, and if they are, write a similarity statement and find the scale factor ABC to JKLM. So first, I want to determine if the polygons are similar. First thing I want to do is check the angles. So A matches with J, B matches with K, C matches with L, and D matches with M. Those are all marked the same, so I'm good as far as angles. Angles are normally fairly easy to check. Either I need to solve for a number to make sure it works, or I can just see how they're marked. Right? Then I want to check my side lengths. Right? So they make this fairly easy for us. We have 12 and 21 as one pair, and 8 and 14 as another pair. But then I have 3 8 to 14s. So they're going to reduce to the same thing. So I'm okay there. Both of those, here if I take out a 3, I get 4 to 7. Here if I take out a 2, I get 4 to 7. So both of those reduce to the same thing. So they are similar. So then I want to write a similarity statement. Similarity statement is just writing out the two things that are similar. They actually make it easy for me here. They give me the two markings, so I just change that 2 to a similarity symbol. ABCD is similar to JKLM. And my scale factor. This is where the 2 here matters. ABCD to JKLM. That means ABCD has to be on top. Okay. When I set this up, I did that anyway. So we have 4 to 7, so that is my scale factor. But you can check this by putting JKLM on top and ABCD on the bottom. That would not, your scale factor then would not be 7 to 4 though. You'd have to flip it because of the order here. So they give you something to something, then you need to have the first one on top. If they don't give you that, then you can pick how you want to do the scale factor. Example 3, they tell us it's similar. BCD is similar to RST. They ask me to find the value of X. Okay. So X matches with 13. Right? So I have, we'll put 13 on top and X on the bottom. Right? Now I need to match that up with 2 of my other sides. What side do you use if you have numbers on here like this is up to you. All right, so we can do 12 to 24. We could also do 5 to 10. Both of those will actually reduce to 1/2. So you could also, if I'm looking at this and I go, oh, I know that's 1/2, I can reduce that. That makes my math easier because I cross multiply, I get 26 equals X and I'm done. Whereas if I'm doing this here, when I cross multiply, 12X is easy. 24 times 13, I probably have to plug into my calculator to get that that's 312. And then I divide and I get X equals 26 again. So again, if I reduce it ahead of time, 1, that gives me my scale factor, which I don't ask you for in this problem, but a lot of them will. But 2, it makes my math easier. So that's something to consider as you're doing it. Flipping the paper over. At the top, we're looking at perimeters of similar polygons. So if 2 polygons are similar, then the ratios of the perimeter is equal to the ratio of the corresponding side lengths. Okay. So basically what this is saying is my scale factor is going to be the same. We look at the triangles we just looked at on this other side. They had a scale factor of 1/2. So the perimeters are going to reduce in that same way. Right? If we add up 12, 13, and 5, we get 30. That was the smaller triangle. So the other one has to be 60 to keep that ratio the same. They express this here, that these are similar. So then they're showing the addition of these. So this is just putting all of those parts together. So KL matches with PQ, LM matches with QR, MN matches with RS, and NK matches with SP. Oops, it's a P, not an R. And all this is saying is if I put numbers on these that worked, all 5 of those things would reduce to the same thing. Okay. Then example 4, and it shows us basically an application for this. A larger cement court is being poured for a basketball hoop in place of a smaller one. The court will be 25 feet wide or 20 feet wide and 25 feet long. The old court was similar in shape, but only 16 feet wide. Okay, so find the scale factor of the new court to the old court. So I want to make sure I'm looking at the same thing. I want the new court on top because it says new court to old court. So I have width here and width here, so that's what I'm going to use. I have 20 to 16. Take a 4 out of both of those, and that reduces to 5 over 4. Right, so that is my scale factor. Again, 4 to 5 would not work because it says new to old. So I need to keep the new one on top. Then it says find the perimeters of the new court and the old court. So if I look at my new court, they tell me, they don't actually state that it's a rectangle, but saying it's 20 feet wide and 25 feet long, it's got to be a rectangle. So I can do my perimeter. Right, 20 plus 25 plus 20 plus 25. That'll be my perimeter of my new court. That is 90 feet. So instead of finding the length of the other court, I can just do 90 over my perimeter equals 5 over 4. Because the rate based on the perimeter of similar polygons theorem, these two ratios have to be the same. So when I cross multiply, I get 5p equals 360, divide by my 5, and the area of the old court was 72 feet. In example 5, right, they ask for find the length of the altitude, right? I don't actually say which triangle. So I'm presuming I'm looking for GL here. That's my height of the whole triangle. Watch in this case, because they have different things that you're looking at. The height of this triangle is 14. The base of this triangle is either 10, or if I look at this one, it's 5. So I can compare either there as long as I'm consistent. So I'm going to go with the whole triangle here, the whole triangle there, because that's what I have written down already. So 10 over 16, which is this length over this length, equals 14 over that whole thing there, which we'll put as A for altitude. Cross multiply, 10A equals 224. So my altitude of that is 22.4. And that is the altitude of that triangle. Right? And decimals are fine. They exist in life. Right? So decimal answers are not necessarily wrong. We're fine with that 22.4. And then lastly, we're looking at area of similar polygons. This says if two polygons are similar, then the ratio of their areas is the square of the ratios of the corresponding side lengths. So if we're looking at the problem above where we had 5 to 4, the area of those two would be 25 to 16. I square both of those. So example 6, it says use the given area to find xy. All right, I have 7 to 28. So first thing I want to do with that, if we're doing a problem like this, is reduce that 7 to 28. 7 goes into both of those, that gives me 1 to 4. Because of the squaring, I take the square root of that. That gives me 1/2 as the ratio of my sides. Okay. For what we're doing in this class, those will always be perfect squares and will work out nicely. In life, that won't happen, but for this class, it will. So then I have this as 4. I'm looking for xy. So I have 1/2 equals 4 over, call that L. so we don't confuse it with that X. Cross multiply, right? And the length of that is 8 centimeters. Example 7. A large rectangular billboard is 12 feet high and 27 feet long. Smaller billboard is similar to the large billboard. The area of the smaller billboard is 144. Find the height of the smaller. So here I have 144 as the height of the smaller, and area of rectangle, I'm just multiplying these two. So that gives me 324 feet based on the 12 to 27. So first thing I do is reduce that. Okay? And this will reduce to 4 to 9. Okay? If you don't see that right away, which most people probably don't, start taking out parts. Like something I know goes into 144 is 12. So I tried that in 324. That gets me 12 to 27. Well, 12 and 27 both have a 3 that come in out of them. That's what gets me to 4 to 9. So then I take the square root of the 4 to 9. That gets me 2 to 3. That's my ratio of my side lengths. And now I'm looking for height. So I do 2 to 3. The 12, right, is the larger billboard. The larger number is on the bottom, so the 12 goes on the bottom. And then this is the height of my smaller billboard. So then I cross multiply. I get 24 equals 3h. H then is equal to 8 feet. And that is our similar polygons.